Work it, make it, do it, make sense.
Yeah, this talk in particular was one that the DevOps conference organizers, the program committee, explicitly requested, because I've been known to talk about a lot of different languages and platforms over the years. And so they said, hey, would you be willing to talk about, polyglot? And well, the problem with the term polyglot is it only addresses languages, and actually I talk about a lot more than that. So I said, okay, how about we expand it slightly? And they said, sure, and let's talk about like how often, how do you manage that as a career? I said, okay, cool, polytechnical careerism. And they said, what? I said, perfect, that's the title. We're going to run with that. That's me, by the way, in case anybody cares. Anybody care? Nope, moving on. So, what the hell is polytechnical careering? Well, to do this justice, really, I need to talk a little bit about the whole notion of polytechnical, right? Because as many people will tell you, poly is good, right? Y'all got that? That's good. Polytechnical sort of embraces the idea that in the beginning there was this language called C, and everybody used it and everybody was happy, the end. Right? Yeah. If you've been around in the programming industry for more than about 5 minutes, you know that we've never agreed on anything, except maybe that the idea that we don't agree on stuff means we need to build additional stuff, right? There's an XKCD to this exact effect. There are 16 competing graphic standards. We must build one to unite them all. Next panel. There are 17 competing graphic standards. Yeah, we've never agreed on anything. And it's been this collection, this hodgepodge of all these different languages, all these different data storage tools, all these different platforms, all these different things that are out there that people can make use of, right? The platforms, I mean, you can go as far back as the early 70s. It may interest you to know that Java was not the first mainstream platform that actually made use of an intermediate bytecode format that was then compiled on target platforms. That distinction actually belongs to Pascal. P-code was what they called the bytecode format back then, and nobody's quite sure whether that stood specifically for Pascal code or pseudo code. Everybody called it P-code. But that dates back to like 1973. Anybody here born after 1973? Show of hands, come on. Yeah. See, I was born in 71, so to all of you. Yeah, all of you are younger than the ideas of computer science that are expressed in the Java virtual machine. Doesn't that make you feel young and stupid? The alternative is to feel old and smart. I'm not sure which is better, honest. I'm really not. There are 3 polys that I will frequently refer to. Polyglot, of course, is the term that many people will cite. First of all, Neil Ford, as far as I know, is the first one who coined the phrase polyglot programming, specifically the idea of using multiple languages. And then I did a little bit of Latin research and discovered that polypraeclusio, many storages. The praeclusio was actually the name of some of the jars that they stored wine and other stuff in. And then polycrepido, many platforms, foundations. Because, quite frankly, as a developer, I have found that having a range of software technologies at my fingertips is a very, very useful thing to have. So, without spending too much time in these guys, polyglot, the idea that basically we've always had multiple languages that we could work with. Now, to be fair, really, the world agreed on C a long, long time ago. And not so much that they agreed on the language C as much as they agreed on some of the standards that C implicitly set. Specifically, if I have a library, if I have an executable, when I get ready to invoke a function, it is described in this way, and the parameters are passed in this way, and the return value comes this way. And as long as we all agree to that, then any language could make use of any library that was compiled potentially by a different language, but usually by the C compiler. As a matter of fact, some of the very earliest languages were actually source-to-source transpilers. This is actually how C++ got started. The C-lang compiler, per se, back in the earliest days when Bjarne Stroustrup was first working on it, was actually a transpiler that took C++ source and turned it into regular C source, which you then compiled with the standard C compiler of your chosen platform. C is the backplane against which a lot of this stuff was built. And that was useful because it meant that if I was working on a new language, I could just leverage those other libraries. And we lived that lifestyle for quite a while. And then along came the web. And if anybody was not convinced that the world was clearly built out of multiple languages, the web most certainly solidified that view. Because now you have to, in order to build a web application today, you have to know HTML. You have to know CSS. You have to know JavaScript. You have to know XML. I mean, you're like, wait, XML, why do you need that? Well, because of all of the various support files and so forth. I mean, you can't be a Java developer and not know some amount of XML, because otherwise how would you write your deployment descriptors and so on and so forth? Oh, and by the way, of course you have to know Java, right? And then you have to know Gradle, the build scripts, or you have to know Maven, which is its own disaster. You have to know all these different languages in order to build a web application. You are clearly having to learn multiple languages. There have been some attempts to try to unify the world under one particular language. There's an effort in the JavaScript world to create a platform called Meteor, which is all JavaScript all the way down. Oh, but you still occasionally have to do some HTML, and oh, there's got to be a little CSS, and sometimes you'll have JavaScript on the back end and the front end, and we could almost, if we squint really hard, think about JSON as its own storage format. Oh, and by the way, when you store stuff, if you store it to a relational database, well, that means you got to know some SQL, or you got to know some Hibernate-flavored version of SQL, or whatever your particular ORM library uses for ad hoc query, and so on and so forth. Excuse me. Whoops. Other direction. The JVM, in many ways, opened up an interesting new development for a lot of people with respect to languages, because the JVM itself was not tied specifically to Java. By virtue of the fact that we could use this bytecode that could be produced from anywhere. There was nothing intrinsically Java-esque about Java bytecode other than the fact that, it's produced by the Java compiler. As a matter of fact, Java 1.0 ships, I don't know, somewhere around 1995, 96 time frame, and probably within 3 months, a gentleman by the name of Per Bothner has actually produced a scheme compiler that produces Java bytecode and runs on the JVM called Kawa, K-A-W-A. Very shortly thereafter, a couple of language researchers actually produce a language called Pizza, because nothing goes better with coffee than pizza, right? I'm like, no, dude, that's for the beer virtual machine. You got that one clearly wrong. But pizza, interestingly enough, introduced some notion of parametric polymorphism, which actually then was supplanted by pizza's successor, GJ, also known as generic Java, which was then replaced by Java 5. The guys who worked on pizza were the same guys who worked on Java generics that we ultimately got as part of Java 5. So this idea of the JVM being one platform, many languages, has been around almost since the introduction of the Java virtual machine itself. And for a long time, that knowledge was kind of left entirely in the hands of the academics, until a gentleman sat down and said, you know what, this notion of object orientation is good, but there are a bunch of problems it doesn't solve very well. I'm going to actually look at a way to try to capture cross-cutting concerns in a consistent manner, because he actually worked on the Common Lisp object system, which supported a full-blown meta-object protocol, and he said that could actually get to be a little too powerful. It'd be nice to be able to restrict that. Let's create a subset of that. He called it aspects. And in 2001, Gregor Kozales shipped Aspect J, and that really opened Pandora's box. Very shortly thereafter, James Strachan started working on Groovy. Around the same time, Martin Odersky starts working on Scala. And of course, everybody knows how that story has since turned out. We now have, what is it, half a dozen popular, mainstream, whatever alternative languages on the JVM, and that doesn't count all of the obscure ones that you don't even know exist yet. Meanwhile, over on the other side of the world, out in Redmond, Washington, where I live, there's this small software company. They make an obscure operating system. You may have heard of them. Microsoft, maybe? Have you ever? No? No, yeah. The only company that anybody knows from Seattle is Amazon or Starbucks. So, yeah, Microsoft saw what the Java guys were sort of implicitly working on, and they made it an explicit goal as a part of the .NET runtime to have one platform and many languages. Microsoft shipped 5 if you squint really hard, right out of the box. And that number has actually only gone up since. Microsoft worked with a number of research universities to experiment with doing various things on the CLR, et cetera, et cetera. We've always had this notion of polyglot. And now today, with the modern web platform and the idea that anybody who knows how to make an HTTP request and consume JSON, well, crap, the world is your oyster. You got all these APIs, all these services that you can consume directly, regardless of what they were written in or what you're written in or anything. HTTP, in many respects, will enable that ultimate level of interoperability that we've always been searching for, because ultimately, all you really need in order to enable this level of interaction is you need to have some known common communication medium, whether that's in memory or whether that's across the wire. We have to agree on some kind of data frame format so that when I send you 5 integers, you understand that these are big endian or little endian or how they're represented. Actually, the frame of format of choice today often is just plain ASCII text. And then some way of being able to identify these things, which of course across the web is generally just URLs, but if we do this in memory, the C interoperability layer I talked about earlier follows all this same stuff, right? Communication medium is basically the stack, the assembly language stack, as long as parameters are pushed in this particular order, et cetera. That's your data frame format. And the identifiers and metadata format, those are described in the file formats of the executable files. So as long as you have these things, your language and my language can get along and talk very, very well. Now, if we want to talk about storage stuff, back in the really old days, does anybody remember a time before the relational database? The relational database is sort of like this giant blotter on all of computer science history. It's almost like nothing ever existed before the RDBMS. Now, it turns out that there were several different storage formats beforehand, but this gentleman by the name of E.F. Codd, a.k.a. Ted, as he was known to all of his friends, so he and I already have a lot in common, and I'm grooving on that, because this guy was ridiculously smart. He is the one who effectively invented the relational data format, the relational model. He's the one who laid down the spine for all of this in 1969. And it took a while for it to take off. As a matter of fact, you could really argue that the relational database doesn't hit its stride until the 80s. Oracle had several versions of their database before it was actually something that people would actually trust. It's hard to remember that there was a time when corporations didn't trust their data to Oracle, but there was a time. And there were all these different ways of representing data. The really funny part about the whole relational thing is SQL, right? That language that we tend to bury behind programming languages. That was originally intended to be something that was directly used by the non-technical people who wanted to get data out of a relational database. The intent back then was literally sit them down in front of a terminal, fire up SQL+, and turn them loose. Just type in some SQL, you'll get your data back in a tabular format. What else could you possibly want? Yeah, because that'll work really, really well. There were a number of different data formats. They usually had their own storage format. Sometimes they were referred to as network storage. Flat files come from a lot of this historical time frame. But the relational data model kind of came along and reset everybody's expectations. By the time we get into the 90s, we finally have sort of a universal agreement that relational data is the only way that you can store data. It's the only way you can put things in place. As a matter of fact, this notion of the relational model is so strong that, again, I live in Redmond, Washington. I have a number of friends who work at Microsoft. And there is a story, I don't know if it's true or not, but it certainly sounds real to me. There's a story that says that Microsoft decided to do a little bit of a technical audit. They decided to look across a standard stock installation of Windows Vista, I think it was. That was the operating system when they chose to do this. They wanted to count the number of relational database implementations. Not the actual number of databases, but the actual database implementations that come out of the box in a stock Windows Vista install. 17. 17 different times, teams at Microsoft said, we need to store data, and we're going to write our own relational database-like thing in which to store it. And that's just out of the box. We really fell in love with the relational database. We really, really did. All the world can be arranged into tables, rows, and columns, right? There is no other way to think about data other than tables, rows, and columns. And then came tags. And we looked at HTML and we said, yeah, HTML is really, really cool. And you know what would actually be really, really cool is if we had sort of an HTML-like format, but for your own kind of data, right? And the notion of, and I'm not making this up, the notion of an Xml browser was born. The idea that somehow people would make something that operated like the web browser, but it would recognize your custom tags and display however you wanted to display that. Nobody ever really explained how an XML browser was supposed to work. They just talked about it, right? And then we sort of got into the, oh, well, XML, yeah, it's not really a markup language like HTML. It's not really about display. It's more about data. And then people started talking about SOAP and WSDL, and we kind of know how that story ended. Fortunately, it did end. But along the way, people started to realize that, wow, you know, squares are useful things in which to store data, but so are triangles. Because the problem with a relational database format is trying to store a hierarchy in a relational format is really, really hard. Have you ever tried to model a company's org chart using tables and rows and columns? And then have you ever tried to write SQL queries that can actually join between the janitor and the CEO to actually find how the path between them goes? And the interesting thing is in the XML space, we invented a couple of tools. First it was XPath and then later XQuery in order to be able to efficiently query this hierarchical data structure. And the best part was we actually discovered along the way that trying to move between objects, which are basically a cyclical graph in some places, going from objects to tables, that's really easy, right? I mean, it's not like that's a ridiculously hard problem that people have been trying to solve for the better part of 20, 25 years that goes by the name of the object relational impedance mismatch. Then trying to map tables to hierarchies, that's even more fun. And there was one open source project I will never forget, Castor, C-A-S-T-O-R, Castor JDO, which was this great open source project that was going to take your object model, turn it into XML, then take it over to the relational database and turn it into tables in order to take it back onto the database, turn it into triangles, then bring it back to your objects as circles again, because there's not going to be any loss and any performance problems doing that. We kind of began to suspect that maybe different shapes to data was kind of important. And we began to suspect that there were some other issues that were appearing as a part of the relational database world that we needed to address. Werner Vogels is the CTO of another small, little-known software company in the Pacific Northwest. Each node in a system should be able to make decisions purely based on local state. If you need to do something under high load with failures occurring, and you need to reach agreement, you've lost. What does he mean by that, by reaching agreement? Well, specifically, there was this feature inside of a relational database called two-phase commit transactions. How many of you have heard of that? Show of hands. Yeah, most of you. How many of you can explain it? And the hands go back down. One in the back. Two-phase commit protocol is actually really, really easy to understand, but the best way to describe it is with volunteers. So I'm going to grab the young lady here in the blue shirt. No, the one that was on her phone trying to hide it from me. Come on up. What's your name? Kim. Come on up, Kim. Now, Kim, one of the interesting things about being volunteered like this is it's better with a friend. So I need you to pick somebody. Pick somebody that you also want to volunteer. Any day. Anybody.
That guy I don't.
Which guy? That guy?
Yeah.
Yeah, the one right in the middle of all of the people, so he has to and you could have picked one in the very back so it would take longer. But what's your name, sir? Paul. Come up here, Paul. So, Paul and Kim, my volunteers, the two-phase commit protocol is actually very, very easy to understand because it's something we see happening in Western civilization pretty much every day, and it goes something like this. Dearly beloved, we are gathered here today in the presence of God in this conference to join together in holy matrimony, Paul and Kim. Do you, Kim, take Paul to be your lawfully wedded husband, to have, to hold, blah, 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 blah? If so, respond by saying, I do. While Paul recovers from his mortification at being left at the altar, this is known as the planning phase in a two-phase commit transaction. I am actually asking each resource that is a part of this transaction to decide whether or not they can commit to the transaction that we're about to perform. Can they do all the work? In this particular case, Kim is thinking to herself, well, I have to now live with somebody who forgets to put the toilet seat down, and my boyfriend might have a problem with this, or husband, or yeah, exactly. Can I commit to this transaction? And she votes either yes or no, okay? Now, the thing of it is, everybody that's a part of this transaction gets an opportunity to vote. So then, Paul, do you take Kim, blah, 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 yes or no? He's got to do the same calculation. He's got to think, man, now I have to actually come home at night instead of staying out with my mates at the pub. I have to actually make sure the laundry hits the laundry basket. I actually have to go out and buy a laundry basket, come to think about it, right? Because admit it, guys, when you're living alone, there's no such thing as a laundry basket. There's the floor and the chair and the bed and the office, right? I mean, whatever. He's got to decide whether he can commit to this transaction. And if they are databases, which is the whole point of this two-phase commit protocol, this is when they have to make sure that everything will work. They cannot run out of memory. They cannot have problems writing to disk. There cannot be any schema violations. So they have to do all of that deciding now. And of course, in the traditional ceremony, we also turn to the audience. If anyone knows why these two should not be married, let them speak now, forever hold their peace. Anybody want to save these two? You're screwed. Therefore, by the power vested in me as an officially ordained minister of the Church of the Latter-day Dude, Dudism.com, it's a thing, world's slowest growing religion, based on the principles of the Big Lebowski. Great religion. I therefore pronounce you husband and wife. You may kiss the bride. Yeah, see, the best part is I never actually let them vote. This is awesome. This is the commit phase. Having allowed them the opportunity to vote, I now have to circle back. Because remember, unlike the traditional wedding ceremony, this is all being done remotely. This is all being done over network lines. And as a result, this means that Kim doesn't know how Paul voted. Paul doesn't know how Kim voted. They don't know how the rest of you voted. It's kind of like an episode of Survivor. Nobody knows except me. I pronounce the results. And I, the transaction manager, say, you're married. The end. And at this point, each of the resource managers flip the bit that says, yes, this data is now live. Now, remember when I said this is all happening over network lines? Those are really slow. As a matter of fact, if you do the math and you try to calculate how much time it takes to go from one machine to another across a heavily congested LAN like what you might find inside a data center, you will actually discover that it's roughly, in human terms, about the same amount of time as it takes to go from here to Pluto, one way. So just asking Kim, can you commit? That's 2 trips to Pluto. Asking Paul, can you commit? That's 2 trips to Pluto. By the way, using today's technology, a trip to Pluto takes about 14 years. 13.7, 13.8, something like that. So imagine for the moment I said to you, hey, I know a great brew pub on Pluto. Let's go grab a beer. So you get in your rocket ship, you fly to Pluto, you grab a beer, you come back. That's 28 years. I just got an okay from Kim. Now I go to Paul, 28 more years. Now I go to you, 28 more years. That's 84 years in accumulated round trips. So 1 wedding ceremony and we're dead. Now, keep in mind that there are 9,999 other people who want to get married but can't because they need you, and you're in the audience waiting for the results of this transaction to complete. Each node in the system should be able to make decisions purely based on local state. That is, not having to go remotely, not having to talk to other partners on the network. If you need to do something under high load, there are 10,000 people who want to get married because for some reason this is now Las Vegas. With failures occurring, because these remote communications will take a long time and failures will occur just because internet, reasons, cosmic rays, who knows? You ever browsed a website and the website never came back? Yeah, failures occur in remote communications. And you need to reach agreement. You've lost. Amazon cannot do 10,000 transactions every minute, every hour, if everything has to be done using this. And this is something that databases do really, really well. But if this is going to inhibit our ability to scale, we have a problem. Did you kiss? Did you? You did? Get out. Go sit down. God, terrible volunteers. Thank you. See, the problem here was that the relational database and its concept of ACID transactions and its concept of requiring agreement was creating contention. 10,000 transactions cannot all happen if they're all sharing the same resources, aka sharing the same database. Contention is the enemy of scalability. And scale is the issue of the internet. There are 10,000, there are 1 million people, all of whom want to use your website at the same time. What we were doing is we were taking a lot of our internal applications and projecting them out onto the web. And as a result, our ability to predict load factors was dramatically reduced, almost eliminated entirely. We needed to find ways to be able to do a lot of these things without actually having to do this transactional protocol. Around 2000 time frame, a gentleman by the name of, I think it's Julian Brewer, I believe he was a professor at the University of Berkeley, University of California at Berkeley. He actually reasoned that what we're doing whenever we talk about database systems is we're building a database system that's based around 3 key characteristics: consistency, availability, partition tolerance. Partitionability, if you want to use that word instead. As a database implementer, you get to pick 2. Imagine a triangle. This is a 3-dimensional graph, if you will. You get to maximize on at most 2 of these things. It's kind of like as a software developer and you go to your boss and you say, boss, better, faster, cheaper, pick 2. Same basic problem. You can't have all 3. You have to let me control at least one of them. The database vendors historically, particularly the relational database vendors, they maximized on consistency and availability. Availability is fairly obvious. A database that's out for an hour while it does some internal cleanup, not going to be particularly useful in a 24/7 world like the internet. Consistency, of course, the data is always accurate. A partition tolerance, the database can be split over multiple servers, multiple disk packs, multiple whatevers. Okay? Well, the relational database world maximized on CA. The NoSQL world that emerged in 2000, starting with CouchDB and then later exploding into a bunch of other things, said, yeah, consistency, not so important. We actually need availability and partition tolerance. I need to be able to grow to much, much larger sizes than what the traditional relational database will support. I need to be able to actually spread my database load over 100 or 1,000 different physical nodes in the network. And if I'm trying to do two-phase commit transactions across 1,000 nodes, forget it, I'm done. There's no way I'm going to be able to make this work at scale. Now again, once we start talking about looking at all of these different data tools, whether we're talking about relational databases, whether we're talking about NoSQL databases, MongoDB, whether we're talking about graph databases like Neo4j and all these other creatures, we have to have a lot of the same kinds of things in order to be able to interoperate between them. I need to be able to understand. Again, a lot of this is basically communication-related stuff. Until I have that ability to communicate between these two guys, however, it's tricky, it's hard. Now again, fortunately, today most of these services are relying on HTTP in some form of HTTP data frame format, XML, JSON, what have you. And meanwhile, the platforms underneath, major piece of software is an operating system, an operating environment, database under which various smaller application programs can be designed to run. Most of the time when we were talking about platforms, we were thinking operating systems. But it turns out that there's a variety of different platforms that have been around for a while. The closest we ever got to any sort of universal platform, platform that everybody sort of agreed on, was back in the day when Windows ruled the desktop. That was the closest we ever got. But Windows never touched the server in that time frame. And realistically speaking, Windows never, they reached a point of dominance, but they certainly never reached a point of universality. There was always those fringe groups, some of who were running Mac OS, Mac OS 7, Mac OS 8, Mac OS 9. And then once Mac OS X came out and Apple sort of rebooted the company, yeah, at that point, any hint that Microsoft may have had some sort of dominant monopoly was lost. And now we've got a ton of different platforms. You've got the desktop operating systems, you've got the server operating systems, but now, of course, we have containers. Docker and its friends are making it much, much easier to, in fact, run in a number of different places. Plus, you've got the mobile platforms. I can't wait for the day when I can run Docker images on my Android device, because you wait, that's coming. Somebody's going to come up with it and invent that and make that work somehow. But then there's also the cloud. The cloud are definitely platforms. The verticals, right? You have various companies that will actually make their platform available for you to be able to extend and use. And that includes the vendor platform. Salesforce would absolutely love for you to build applications on top of their platform. And I'm not talking about Heroku. I'm talking about actually building things that extend the Salesforce applications as they currently sit, using data that's stored in Salesforce, et cetera, et cetera. Facebook, Twitter, these guys are people that they would love to see you build applications on top of their platform. Again, in order to be able to communicate, we need some of those basic communication factors in order to be able to make all of this stuff work. And you're saying, dude, you just spent the last half an hour going through a whole list of stuff, some of which I've never even heard of. Why exactly do I want to spend time studying all this crap? Because seriously, I actually have a life. Obviously, I don't, because I'm studying all this crap. But truthfully, there's a lot of pain that will come with trying to live the poly lifestyle, to actually try to embrace all of these things. The first obvious thing is you have to have time. You have to make time somewhere in order to be able to figure out how all of these things work, much less how they work together. And in many respects, the concern here is, well, yeah, if I spend a year, say, studying C#, and then a year studying Java, and then a year studying JavaScript, and then a year studying Haskell, and then a year, well, first of all, that's 5 years that have just elapsed. And second of all, what have I really gained for doing all of that? And on top of that, what practical purpose does that really serve? Because, Haskell is a language that compiles to native binary executables, But Java code compiles to Java class files, and the CLR compiles to .NET assemblies, and it's not like those things work together out of the box, so now I have to think about how they're going to work together if I'm somehow going to make the argument that knowing all of these things is actually practically beneficial. And on top of that, the way in which Java approaches designing a system is very different from the way in which Haskell approaches designing a system. So what happens when those two mindsets clash? Seriously, this kind of feels like you're chasing after dreams. Well, the interesting thing is, in many cases, it's not about directly creating technical solutions. In many cases, it's about changing your mindset, your worldview. If you are an object-oriented programmer, if you grew up knowing nothing but Java, if you started programming, say, 1998, 1999, if the first thing you ever wrote was the Java Hello World, nothing seems wrong with public, static, void, main, parens, string, bracket, args, close parens, curly bracket, and we haven't even gotten to do anything fun yet. Remember the first time you learned Java? Especially if you'd never learned any other programming language ever, right? And you said, okay, well, what is this? Public class hello. Well, class indicates we're creating a class. Well, what's a class? Well, a class is what we use to make objects. Well, what's the difference between a class and an object? Don't worry about it. Well, what's this public thing? Well, don't worry about it. Oh, okay, so what's this public static? Don't worry about those either. Void, well, that's the return type. Okay, that means that I'm going to be generating a value? No, void means you're not returning a value. So I'm basically saying that I'm not returning something? Yes. So why don't I just leave it out? Well, you can't. You have to return something. But I'm not returning anything. Don't worry about it. Now you write main. Well, why does it have to be called main? It just does, goddammit. There's a lot of stuff that we kind of took on faith back then. Meanwhile, you go talk to the Ruby developers, and their hello world is puts hello. That's it. That's all you got to do. That's it. And you're like, wait, why is Java better than Ruby again? Oh, yeah, the static typing. Yes, because the compiler actually will be able to determine when you're working with particular types and when when you're doing it wrong, which is why, of course, that when I put a string into a list of objects, I have to explicitly tell the compiler that this is a string when I pull it back out of that list of objects, because I know better than the compiler does, even though the compiler is the static type checker that's supposed to be saving me from making any sort of type mistakes. And the compiler will be like, oh, okay, sure, that sounds great, man. And then when it's actually an integer, it blows up at runtime. But the compiler is the one that's saving you from making all of these mistakes. Right. Yeah, there's a lot of interesting problems that start to emerge, particularly then when you as a Java programmer walk up to a subject matter expert and start asking them for what are the business validation rules around this. And then you start discovering, oh, well, okay, if somebody wants to rent a car from us, then if it's on a Friday and the reservation extends across the weekend, we charge them twice as much. Unless they're a silver customer, and then we only charge them half as much. Oh, unless it's over a holiday. And then we actually charge them twice as much, which means we charge them twice as much twice, then divide it by half, so we're actually only charging them by twice as much. Oh, unless their last name begins with a Z. And you got all that, right? You wrote all that down, and you got the exact order of priority here so that the numbers come out exactly correct, and you actually have verified this with all of the subject matter experts, and if you've never, ever wanted at some point to just turn the keyboard and shove it at them and say, fuck this, you do it. Wouldn't that be great? Seriously, think about that for a second. Wouldn't that be awesome? To just turn and give it to the business analyst and say, you do this. Because there are actually languages where people are trying to do exactly that. There are platforms that we're trying to build that will let non-technical people do exactly that. This was kind of the whole point of the domain-specific languages model. But that maybe that's too much, right? Because at the end of the day, if we don't have to have programmers, then what are they going to do? They're going to fire the programmers, and then we're out of a job. No, that's not so good, right? But when I go out hiring for developers and whatnot, and I'm looking for developers, all of whom have at least 5 to 10 years of Java experience, because trying to understand Java, trying to understand HTML, CSS, JavaScript, SQL, XML, Gradle. I mean, you're not going to get that right out of college, right? No university teaches Java EE 5.0, right? Much less Java EE 7.0. And it's really easy to find senior Java developers with at least 5 to 10 years of experience, right? I mean, they're just hanging off trees waiting to be picked. Instead, what we're getting is a whole bunch of people who are making career changes, learning like JavaScript, MongoDB, and AngularJS at a coding academy in 9 weeks. Yes, and now this is your new team, and you need to work with that. And the best thing is to like throw them in front of a Java IDE. Here, this is IDEA. Write some Java code. Don't screw it up, though. Well, Java's like JavaScript, right? I mean, they're kind of the same thing because they're all based off of the same name, right? Yes. Java is to JavaScript like ham is to hamster. Sure, let's run with that. Awesome. Yes. I'm sure you will be a productive member of this team. Actually, if we had the ability, think about this for a second. The JVM has an implementation of JavaScript on it. It was originally called Rhino. Now it's Nashorn because they had to rewrite it for some God knows reason why. What if a significant part of your code base was written in JavaScript running on top of the JVM? What if somebody actually ported Express.js to run on top of the JVM? What if you were the person that built the necessary hooks between the JavaScript business code that talked to the underlying platform to do all of that stuff that the JavaScript developer could never possibly understand, and now all of a sudden you're gathering these coding school graduates and filling out the jobs that you couldn't find senior Java developers to do? How popular would that make you with your boss? In some cases, we don't actually even want to run it through IT. We do want to run certain things past the marketing department. Let them make their own changes. Let them change some of the stuff that they're working on. What if we built the application in such a way that effectively all of the business rules were written in some other language so that we, the developers, didn't have to worry about it, and we could actually train business analysts once they gather the rules to actually write them themselves and plug them into the running system? In some cases, we've got these really, really complex logic problems. Anybody ever tried to schedule all of the employees at a fast food restaurant? Trying to remember that Lawanda needs Wednesday off from the time of 4 to 6, and Fred has classes on Mondays and Wednesdays and Fridays from 2 to 7, and trying to put all of that together is like the world's most annoyingly complex Sudoku puzzle. And there are logic languages that do exactly that. There's one called Prolog that does exactly that kind of solution. And in some cases, it would be really, really cool if we had languages that were absolutely produced specifically to a single purpose, like, I don't know, Gradle. I mean, think about this. Gradle is basically a language specifically for building software. Just like Make was, just like Rake is over in the Ruby world, SBT in the Scala world, lining in over in the Clojure world. Yeah, having all of these different tools at your fingertips can actually make certain problems a lot easier. Because in some cases, the requirements don't fit in one particular tool that we've got. Combining them is the only way in which we're really going to be able to accomplish anything meaningful. And so if you're going to have a team with a wide range of skills, because that's a given. I mean, not everybody is going to be a 20-year industry veteran, and even if you had a team full of those, They're not always going to agree. They're not always going to have the same background. One guy will be like an ex-C++ programmer. One guy will be an ex-COBOL programmer. One guy will have the same single year of experience 20 times because all he did was basically write Python scripts every day for whatever reasons. You need to embrace the idea that there's all these different tools out there and more of them that we can gather under our umbrella in a coherent and consistent format. The better off we'll be able to adjust to all the various things that life will throw at us. The one argument I hear from a lot of people is, this could never work. You're up there on stage, you're at a conference, there's no way that this could practically happen. There's this guy in the United States. We miss him terribly. His name was Barack Obama. 9 years ago, he decided he wanted to become the first black president of the United States. And a group of people threw together, and I do mean threw together, in 583 days, from start to finish, 10,000 requests per second, 2,000 physical nodes, 3 data centers, 180 terabytes, 8.5 billion requests. None of it was architected. It was all thrown together. People with PHP background, people with MySQL background, people with Java background. Because remember, campaigns in the United States are a volunteer effort. They didn't get to pick the kinds of people that they got walk through the door. They just had to do with what they had. Yeah, it could never work. Tell that to the Republicans. So how do you do this? If you're interested in this polytechnical approach, how do you do this? The key thing you want to remember is this. The T-shaped individual. If we look at the idea of the surface layer here being this is the number of different technologies you know, and the vertical is the degree to which you know them. You don't want to be an I-shaped individual. You don't want to be somebody who really, really knows the JVM to an exceedingly deep level. I mean, you could. Brian Getz is a buddy of mine. We've spoken together on the No Fluff Just Stuff tour in the United States for 6, 7, 8 years together. Know him pretty well. Brian and I were talking shortly after he got to Oracle, after Oracle acquired Sun, and Brian became the Java language architect. And I said, so, dude, when are you going to get bored with being the Java language architect? He said sarcastically. And when are you going to, go find something else to do? And he looked at me and he said, what else could I possibly do? Seriously, going from the Java language architect to what? You're going to become a director of software engineering at some podunk startup? I don't think so. Brian is very definitely, every day that he's in that role, he becomes deeper and deeper and deeper on the Java language. Now, don't get me wrong, that's not how Brian's actually managing his career, but that's the danger. If you become too deeply vertical in some space, you end up getting pigeonholed. You can never really break out of that. There's a gentleman by the name of John Robbins in the .NET world. He's known as the bug slayer. Nobody asks him to architect systems. They only call him up when he can save them from some weird production bug that nobody can figure out. The danger of being too deep in any one area is you have no breadth. You can't do anything else. You need to have some breadth to it. You need to study some other things. Now, you can't go deep on everything. You don't want to be the block-shaped individual because nobody can really approach that. But in order to get to this, you have to wake up one morning, you have to look in the mirror, and you have to say, I'm going to do that. I am going to embrace an aggressive plan of self-education. Your company will not train you. I'm sorry, those days are gone. Your company will not train you. Your company may occasionally pay for you to go to a conference and listen to some long-haired hippie up on stage talk about getting people married or whatever the hell that was. That's not training. That's teasing. I talk about all this stuff, but let's be blunt. There's not a whole lot you can gather in a 50-minute period of time except how to get started and how to dive a little bit deeper. It's on you. You have to decide for yourself that you're going to learn deeper on whatever it is that you're excited by. It has to come from you, and you have to be aggressive about it. You have to force this time out of whatever else is going on in your life. You have to formulate what I call a personal ontology for technology. An ontology is effectively a categorization system. So when I say Haskell, you think programming language, functional, right, yeah, I know where that sits in the world. And I say F#, and you say, what's that? And I say it's an object functional hybrid language. And you go, okay, so it sort of crosses into the object and the functional world. Oh, okay, can I write that on top of the JVM? No, F# is a .NET language. Okay, so it's an object functional language for the CLR. There, I've just basically told you where F# fits in my world. Where does that fit in your world? You need to start thinking about what the technical landscape looks like and how it's going to embrace or engage all of these different things. You need to build one of these for yourself. ThoughtWorks likes to call them technology radars. And the key thing here is you need to pursue stuff that isn't just like what you already do. How many people here know Java? Show of hands. Great. Every one of you who raised your hand, you do not need to learn C#. Because guess what? C# is Java. More or less. Well, actually, less. Well, more, because C# has more features than Java. But never mind that. You don't have to learn C#. You do have to learn Scala. Or you do have to learn Clojure, because they are really, really different. Hey, Mark. No, come on back. I needed you as a volunteer earlier. What's that?
You need somebody without a voice.
I need somebody without a voice. That's fine. Just stand here and look pretty.
Okay.
Stand here. No, that's creepy. Just face them. When you get to these new technical bits, you need to have your own evaluation function. You need to have some kind of project. Just stand there. Just don't do anything.
Can I sit?
No. Okay. This is what you get for setting me up with a blind ignite, jackass. Anyway, you need to have some way of being able to evaluate these different technology bits, what I will call an evaluation function. You know all those to-do lists that people are building right now in the JavaScript world? Don't take that. What, now you're drinking in front of everybody? Jeez, just go. Clearly you're terrible at this. You need to have some way of being able to evaluate all of these different technologies, right? The to-do list is a little too small. What's an application that's important to you? What's something that's useful to you? If you're a member of a church, could you build your church directory in this thing? If you're a member of a sports team, could you run the league off of this thing, et cetera, et cetera? Whatever that is, it's got to be personal to you because you're the one that's going to build it using said technology. And the key thing here is, if you try to study everything, you're going to basically be running in directions and accomplishing nothing. Do not mistake motion for progress. You need to be focused on what you want to turn away. You may say to yourself, I don't really care about the mobile world. So therefore, I'm not going to study that stuff. Or maybe I only care about Android and I don't care about iOS. I'm only going to focus on the things that are critical. If you run a team, you need to embrace the idea of Polytechnical. You need to deliberately hire diversely. Secondly, you need to establish a formal dissenting position. When people have opinions, you need to establish what's called the loyal opposition, the dissenters, that will specifically argue with your decisions. Because that's the way we're actually going to figure out where the edges are. I'm almost done. Just relax. You need to make sure you couch all of this in non-technical terms so that we're focused on what's important in the business world. And lastly, you need to discover where the core business is and where it isn't so that you can focus on the important stuff, which is to accept that not everything is going to be the same. Because quite frankly, if we're all the same individuals, there's nothing interesting, there's nothing exciting, it's all boring. Oh, fine, I'm done. Be that way. Shoo. Go. Don't you have a conference to run or something?